Welcome in chapter 12 of class 8. Its name is Mensuration. We are now going to discuss surface area and volume in this class of 8. For that, we have to a quick view of our earlier classes. And in the earlier class, we have discussed already two-dimensional shape. Two-dimensional shapes are a mathematical figure which has length and breadth only. In a layman way, we can say that those figures which can only be touched are of two-dimensional shape. In that category, I have mentioned here 5 of them are rectangle, square, triangle, parallelogram, circle, and you may say there are quadrilateral, circle, and polygons. For that, we are well acquainted with area and perimeter of these figures. For example, rectangle has area of length and breadth. That is, we say it is product of its length and breadth, and its perimeter is nothing but sum of all of its sides. In short, we can write it twice the sum of length plus breadth. Square is a quadrilateral whose all sides are equal and all sides are perpendicular to each other, and its area is side square, and its perimeter is again sum of all its sides, that is 4a. Again, it is triangle is a polygon of 3 sides, and its area is half into breadth, base into height, and its perimeter is sum of all its sides. Here it is a plus b plus c, and then comes its parallelogram. Parallelogram is a quadrilateral whose opposite sides are parallel, and its area is product of its base and height. Height is the altitude of on b, and its perimeter is again the sum of all its sides, that is twice into length plus breadth. And then circle is the area of circle is pi r square, where r is the radius and its perimeter is 2 pi r. Now we are moving to our this class, that is to find the area of trapezium. For that, we have to know, we are well aware that a trapezium is a quadrilateral whose 2 sides are parallel, and here a figure is mentioned, that is ABCD is a parallelogram where AB is parallel to DC, and AB and DC, which are the parallel sides, are called bases, and here AB and CD are bases, and its height are DL and CM. DL is the altitude from D to the sides AB. Now, how to find the area of trapezium? For this, I have done 2 perpendiculars from D and C on A and B. So the trapezium is divided into 3 parts. First, in triangle ALD, and again another is the rectangle DLMC, and another triangle CMB. So these are the mutually exclusive figures, and area of trapezium is the sum of these 3 mathematical figures. We know that area of a triangle is equal to half into base into height, so we can sum up. Here it is AL into DL plus LM into DL plus half BM into DL. So you see here DC is parallel to AB and DL is parallel to CM. So DLMC is a rectangle and so Lm is equal to dc. So we can in short write it as a half into AB plus DC into H. So AB plus DC are the parallel sides, so we can easily find out the area of trapezium from this formula, that half into sum of parallel sides into height. Now again we are going to find area of general quadrilateral. A quadrilateral, we know that a simple simple closed curve which has four sides. Here ABCD is a quadrilateral, and we are going to find its area by triangulation. Triangulation is a process where we divide a quadrilateral by its diagonal. Here we have drawn two altitudes on AC from B and D. So area of quadrilateral ABCD is equal to area of triangle ABC and area of triangle ADC. So area of triangle ABC is nothing but half into base AC into altitude H1 plus area of ADC is equal to half into AC into altitude H2. So in short we can write it is half into D into H1 plus H2, where D is the length of the diagonal AC. So now we are going to find another special kind of quadrilateral, that is rhombus. A rhombus, we are well acquainted, it is a parallelogram whose diagonals are perpendicular to each other. So here ABCD is a rhombus whose diagonals are D1 and D2, that is AC and BD respectively, and AC and BD are perpendicular to each other at O. So area of ABCD is by the triangulation area of ABC plus area of ADC, and we can easily find area of ABC is equal to half into base AC into altitude OB, and area of ADC is equal to half into AC into OD. That is, in total we can write half into D1 into D2, that is the area of a rhombus is equal to half of the product of its diagonals. So now we are going to find another kind of polygon. What is a polygon? A polygon is a simple closed curve made up of line segment. Here A, B, C, D, A is a polygon. So we have done the same way, we have divided it into three triangles. Those are ADE, ACD and triangle ABC, and on all the triangles we have constructed three altitude from E to AD H1, from D to AC H2 and from B to AC H3. So area of triangle ADE and area of triangle ACD and area of triangle ABC constitute the area of polygon ABCDE. So we can easily find off in the area of any number, a polygon of any number of sides. So now we are proceeding for our next topic, that is to find the surface area and volume of a three-dimensional object. What is a three-dimensional object? A solid geometry consists of three-dimensional figures like cubes and spheres. So cube, it's are cuboid, cylinder, sphere. We have this Rubik cube. This Rubik cube is an example of three-dimensional object. Three-dimensional because it has length, breadth and height. Likewise, there are lots of boxes, books, geometry box. We are well acquainted that they are three-dimensional objects. A cylinder. A chalk we use generally in our classroom are example of cylinder. Then this is this is also an example of cylinder. There are some figures I have already mentioned in our PPT, that is cuboid, a cube, a cylinder, a sphere and pyramid. These are three-dimensional objects. We can only not only touch it, but also we can hold it. So there are two things: surface area of a cuboid and volume. So first we will find what are the surface area of cuboid. Surface area. This cuboid. This is a cuboid. This has total 6 number of faces. So its surface area is the sum of area of all of its sides. There are 6 surfaces, so its area is equal to twice length into breadth plus breadth into height plus height into length, and its lateral surface area of a cuboid. Lateral surface area means the area of 4 walls of your room. So its area is equal to twice the product twice into length plus breadth into height. So in this continuation we are going to find out the total surface area of cube. What is a cube? A cube is a special kind of cuboid whose length, breadth and heights are equal. Total surface area of a cube is equal to L square 6 times L square, that is 6L square, and its lateral surface area is equal to 4L square. And the surface area of cylinder. A cylinder has two kind of surface area. One is the curved surface area and another is total surface area. The curved surface area is equal to perimeter of the base into height. The base figure of a cylinder is a circle, so its perimeter is 2 pi r and its height is h. So its curved surface area is equal to 2 pi r h, and total surface area of a cylinder has 3 surfaces. One is the curved surface area and another are its top lid and its bottom lid, that is pi r square plus 2 pi r h plus pi r square, that is 2 pi r square plus 2 pi r h. Now we will find what are the volume of a cuboid. Volume of a cuboid is very simple. It is area of the base of the cuboid into height. The area of the base of the cuboid is length into breadth and its height is h. So the volume of a cuboid is equal to L into B into H. So very simple, the volume of a cube is equal to area of the base into height, that, and we will replace the LBH of a cuboid by L, that is it is L cube. And now the volume of the cylinder. The volume of the cylinder is in the same pattern, the area of the base into height, and area of the base of a cylinder is pi r square because it is circular and its height is h, so its volume is equal to pi r square h. So now we will see the volume and capacity. Volume refers to the amount of space occupied by an object. So when we put any object, so the space it occupy, it called volume. And capacity is the quantity that particular object is able to contain, is able to hold. For example, if a water tin holds 100 cubic centimeter of water, then capacity of water tin is 100 cubic centimeter. We can also associate the capacity in terms of liters. For example, if a volume of a object is 1 cubic centimeter, it means its capacity is 1 milliliter, and if some jug has a volume of 100 cubic centimeter, it means its capacity is 1 liter, and if a bucket has a capacity of 10 lakh cubic centimeter, then its mean its capacity is 1,000 liter. So now we are at the end of this topic, and have a quick check. Area of trapezium. Area of trapezium is equal to half of the length of the parallel sides into perpendicular distance between the parallel sides, and the area of rhombus is equal to half the product of its diagonals. And surface area of a solid. Surface area of a solid is the sum of the areas of its faces. And what are plane figures? Plane figures are all about flat two-dimensional shapes such as circle, rectangles. And solid figures. Solid geometry consists of all three-dimensional figure like cube, sphere, etc. It's mean in a layman language we can say those objects which we can hold is called a solid figure. At the end, these are the link of resources available, and we can get lots of material for our use. Thank you.